Hello everyone, happy Friday. I'm Brady Volpe, founder of the VolpeFirm and Chief Product Officer at OpenVault. Welcome to today's live stream, broadband insights, industry trends, and competitive moves. We've got a packed agenda for you. At Reddit Rants and Raves, we'll dive into recent user feedback on Starlink and Google Fiber straight from Reddit. We're also going to talk about CommScope's big move. What does their acquisition of Casa's VCMTS mean for the future of our networks? And we'll talk a little bit about low latency DOCSIS. How does this technology impact and boost our user experiences? And who better to explore these topics than the true maestro of the cable industry? Please welcome back the one and only John Downey, Senior Industry Consultant. John, it's great to have you back with us again today.
It's always great to be here. I always follow the ones you do with Ron also, which is great. And you're always doing a lot of podcasts, so keeping the industry on its toes.
Yeah, no, we love having the ones with Ron because they get back to basics in our Back to Basics series. So if you haven't seen those, please tune in and get some Ron into your system for some of the Back to Basics. So John, we got some interesting things to talk about today. We're going to start off with an interesting article from Light Reading, which some of you may have heard. Pop it up on a screen here. It's talking about CommScope will ride one VCMTS in the wake of the Casa deal. And John, you may have heard of this. I'll thank Light Reading and Jeff Bumgardner for putting this article together, which we're going to elaborate on a little bit here. Some of you may have heard that Casa unfortunately ran into some hard times and had to sell off their products, I think through bankruptcy, and CommScope was the lucky winner of that deal. CommScope is going to move forward with Casa's integrated virtual cable modem termination system, VCMTS, following the acquisition of Casa's cable assets, says CommScope's Guy Saharchak. And this is from the Light Reading article.
So let me comment right away.
Okay, you go ahead.
I think it's a play on words too, because when you say integrated virtual, that's like an oxymoron. We had integrated CMTS.
And the ICMTS.
We had virtual CMTS.
The VCMTS.
But when I read this article further in, they were basically saying they're going to integrate two virtual CMTSs into one. So the title is very misleading.
And this paragraph on the next
virtual
one talks about that. Yeah, we're going to combine those products, which you're saying those two VCMTSs, and have a VCMTS product in the end, said Guy Saharchak, SVP and President of CommScope Access Networks. We can't have two VCMTS products in the market for a long period of time. It can cause confusion. So back to your rant, John.
It doesn't cause confusion. It causes lack of sales. You know, you're going to have one that people are going to buy and something you want to put all your effort into the one and make it like solid, right?
A solid VCMTS, a solid product is what you're saying.
Yeah, solid product. But you can see it says intends to integrate its virtual, but whoever did the title line from the previous page, we're going to do an integrated virtual. That's not what they said. We're going to integrate its virtual CMTSs from Casa and from CommScope. And remember, CommScope is what? Aris, C-Core?
Back where we all work together? Me, you, and me.
But yeah, it was it dropped down. It was Aris bought C-Core, and then CommScope bought Aris, right?
Correct.
Yeah.
Well, and that's I've not seen a CommScope VCMTS. I've never worked with one before, so I am curious if you've seen it or if any of our viewers have seen it. Drop us a note in the chat. I see we got some folks in there. Welcome to the chat. I'm in the mix like the Czechs. Hello, welcome. James Long, welcome in the chat, folks. Let us know in the chat or drop in the comments below if you've worked with CommScope's VCMTS. Love to know what your experiences are, or, again, if they're out in production, would love to know what the CommScope current VCMTS is, because we'd like to see, what is that integration of the Casa VCMTS and the CommScope VCMTS. I'm very curious, how people have experienced those. I have worked a little bit with a Casa VCMTS, just from an integration standpoint on working with that on UTSC Spectrum Analyzer and on PNM, but I've never actually from a, for DOCSIS standpoint, optimize the Casa VCMTS. So I'd love also to hear from our viewers either in the chat or drop us a comment below. What's your experience with a Casa VCMTS? How's it perform? How's it work from a troubleshooting standpoint? Utilization, etc. What's your experience on that? John, have you had experience with either of these products before?
No, and I knew people that worked there, but I didn't. When we talk about CommScope, I assume we're talking about Aris, an Aris product, and I didn't know where that was going. I didn't get the chance to work with one, so I'm not even sure.
Yep. So James Long says, he says, one good, better than two mid. so I guess, it's like, I don't even want to say that. Thanks, James, for the input on that. But John, I think you make the comment about, where's really CommScope going with this? Where are we as an industry? So CommScope now has acquired the assets or the VCMTS from Casa. CommScope, we know, it's public knowledge. They have $9 billion of debt that they have their own challenge with, and CommScope is also, they've been selling off. They sold off their modems, I think they're also selling off their software or trying to find a buyer for their software and stuff. And now they're acquiring this. What is the opportunity? Do they have an opportunity to really make the money back on buying this? Because if we look at the market, and I'll point out to further down in the article, Jeff Hayman, and Jeff Hayman does a lot of great things from a looking at the market, the industry, looking where we're going, and from a strategy standpoint. He really says, if we pull this next slide up, he really talks about, the market's not going to come back to pre-COVID days. And a lot of that has to do with fiber. So he kind of says there's still concern about what this opportunity is going to look like, because our HFC market is really in decline. We're not we're not where we are in 2013, 2014, where we're just continuing to increase subscribers. Cable operators have a lot of opportunities now. They can deploy DOCSIS, but they can also deploy fiber. And a lot of operators are taking that opportunity to, go DOCSIS where they have the opportunities to still make revenue. But if we're looking at greenfield, they're probably going to deploy fiber. Or if they have, and we're going to talk very shortly about the competition zone, where they're in competitive environments, they almost need to deploy fiber in order to stay competitive with those operators that are deploying fiber. And so I think this is a real key piece of, it's really something we need to look at, is diving deep into this type of venture. It's going to take CommScope a while, in my opinion, to put these two VCMTSs together and have a product. It's not like they're going to have a product in a month. It's probably like they're going to have a product in a year or 18 months, which is a typical hardware development cycle. Your thoughts on that, John?
So, you've been in the industry long enough to know that you don't jump in the water unless maybe someone said they had a lifesaver for you or a paddle boat or something. So I suspect, and this is just my speculation, is the big dogs, the 800-pound gorilla is Comcast. The other big dogs, Charter, those guys, they're always going to want a second vendor. And I'm sure they've had talks in the background that, hey, this is probably a good deal for you guys. Grab it, and we'll use you as a second supplier. And even if you were a second supplier of $1 billion industry, that's a lot of money,
Yeah.
So, Cisco's getting out of it, so that opens up some doors for other people. It's not as diluted, I think. So them picking up the VCMTS, and Harmonic's got their own virtual CMTS, right? Or software.
I think that's an excellent perspective. If we look at the industry, that really there's only two players then, right? Harmonic has been the VCMTS player in the market.
Yeah.
Who's the number 2 VCMTS player in the market now?
Yeah.
It really becomes CommScope.
Yeah.
So,
So I
so
think that's
CommScope may be
probably
doing the right thing in positioning themselves to say, if you don't want to buy from Harmonic, we are your number 2 vendor. We are the people you're going to go to for
yeah,
that second quote, for that competitive quote.
yeah.
So
And if
there
and if
could be a
there's a
good thing.
supply and demand issue or supply chain and Harmonic can't provide, sometimes we all know it's timing. I
Yes,
need something right now. It might be not what I'm used to, but it's just as well or it's just as good, but I need it right now.
right.
So how do I get that? Well, let's go to the second vendor.
And I think traditionally we've seen this in the industry, particularly on the cable modem side. We've done a really good job as an industry in keeping 2 cable modem vendors
Yeah.
alive and well. And well, let's say alive. I'm not sure well, but we've kept 2 cable modem vendors alive because it's necessary. It's necessary to have competition. It's necessary from a pricing standpoint, from an innovation standpoint, technology, etc., etc.
Legal standpoint.
Yeah, legal
I want to
standpoint.
be a monopoly. Yeah. I mean, that's sort of what we had the problem with Broadcom, right? That's why Intel got into it. And then we looking at Max Linear and other chipset vendors and stuff like that, besides just Broadcom. And a lot of times you want to keep the competitive spirit going to keep them in check.
Yes.
You know, if not, if there's only one vendor, they don't have the incentive to keep their quality up either. If there's only one vendor.
Keep their quality up and their pricing down. So,
Yeah, I
but
saw James just wrote Vecima, right?
yes, yeah.
Yeah.
Redacted. It got redacted before it came out. But Jeremiah says, "Is it similar to comparing an Aris E6K versus Casa C100G CMTS, or is this an entirely different realm?" So I would say those are kind of
Those
similar,
were
right?
integrated.
Those are the ICMTSs or the integrated CMTSs, where you buy a box and you have everything you need in that box. You have the software, the hardware, the RF connectors on the box.
Yeah.
Whereas the VCMTS, John, I'll let you describe the VCMTS for us.
I mean, as soon as you go virtual, you're taking the RF out of the box, and now that box could be all software related. It could be a 1 or 2 RU data bank of servers that you line up, and the software is on there, but it's digital output, and it's just fiber optics or 100 gigabit Ethernet feeding out to a node that now turns that node into the RF side of a CMTS used to be, right? You're putting the
Yep.
RF connectors out there, and now you're using the remote PHY device, remote MAC device. Most people sort of lean towards a remote PHY device because of beta versus VHS.
Yes.
That's my analogy, right? It's like whatever came out first, there's a lot more of it. It's cheaper, it's proven, RPDs are easy.
Well, and there
Are
are
easy,
pros and
or they're
cons
pricey.
between the 2 devices depending on who you are as an operator. The integrated CMTS is, I would say, very easy to deploy. You're buying a box, you're putting it in your head end, and you're
And you're integrating with the rest of your video services that are already there. All you're
exactly.
combining, everything's already there.
And all of your head end optics stay exactly the same. You don't have to touch any of that. With a VCMTS, but there are some drawbacks. Before I go to the VCMTS, there are some drawbacks with the integrated CMTS. As far as expandability, it does consume a lot of power, and all that power is going to be in your head end. The heating and cooling is all going to be in the head end. With the VCMTS, you do get some more expandability. As John said, you just have a server in your head end, so it's going to take less power, less heating, less cooling. You're pushing all of your RF out into the outside plant where the fiber node is, so you're going to get really clean RF signals in your outside plant.
Small service areas,
Yes,
right? Very
exactly.
small service areas.
But you do have some now added complexity because now you're getting rid of all the analog optics, all the optics that you're currently using. You have to put in some new equipment, some new switches, some new routers, 100 gig or at least 10 gig switching that you may not have had before. And the configuration of this is going to change. And some test equipment's going to go away that's not going to be supported with this. And also you're going to have to change probably if you had analog video, that's going to be gone. And probably some of your digital video is even going to change in the way that you manage that. So again, there's trade-offs. There's pros and cons for both systems. But there's reasons that people are going to the VCMTS, and a lot of that has to do with DOCSIS 3.1 and wanting to get really focusing on high-speed internet with vCMTS, and it makes that transition a little easier, but the video side gets a lot more complicated.
Yeah, definitely. I mean, if we were all pure digital, if the head end was pure digital, it would probably be easier to push EPON and GPON.
Yes.
You know, but it's not. We still have a lot of not analog. We have MPEG-2 video, so you have MPEG-2 set-top boxes. That's different than MPEG-4. That's usually IP video,
right? Which
but
can more easily be transmitted over a vCMTS than older MPEG systems.
Yeah. So if you have MPEG-2 video, you can still have those QAMs coming out of your RPD out of the field, and then you can keep your existing set-top boxes, which could be millions of them. That's a hard pill to swallow if you're just going to rip all those out. But that's where we're going anyway.
So I'm excited to see how this plays out for CommScope. I definitely wish them the best of luck, and we're going to see what happens over time with the new vCMTSs integrated together with CommScope. So, John, we're going to move on, and we're going to talk about the competition zone. So we have, we're going to talk about both Starlink and Google Fiber and what they're having. We've talked about Starlink before. We're going to start out with them. And I titled this first slide, Like a Fine Wine. It gets better over time. And this really comes from a Reddit article that appeared just 2 days ago, actually, 3 days ago, because I put this slide together yesterday on the subreddit Starlink. So anyone can go out and see this and verify my data. And the user that started this was Clean Vanilla 4732. So you can search this person up. What I liked about this is, John, we've talked about Starlink, and we're like, well, how good is it? We can't really find any good user information on it. Clean Vanilla 4732 has been tracking his performance on Starlink over almost the past year. And he said, he's had ups and downs with Starlink, but his position on it is starting in 2024, Starlink has really meant business when it comes to things like, something we look at in DOCSIS is latency. And he's measuring on ping time. So he's like continuously doing a ping. And he says, since 2022, he's really noticed his ping drop down, with a minimum ping time being around 15 milliseconds. And Clean Vanilla 4732 is a first-person shooter FPS gamer. So anyone who's into gaming and is into first-person shooters, they really, and I'm one of them, so they can really appreciate that latency and latency consistency, and ideally the lower the latency is, really can impact gaming performance. And we also know that impacts other things like real-time voice, real-time sessions like you and I are doing right now. That's going to impact it. Consistent latency, we want, that's important, but latency variations, and he gets into that. I'm going to show a chart in just a moment of him tracking that over the past year, which I think really helps appreciate that. But latency variation is what can also impact it. So in this next slide that I have up, we can see, so this user on Reddit, he's been tracking that continuously over the past years, since August of 2023 till June of 2024. The top line on this chart that I'm showing shows back in August, he was getting about 45 milliseconds of latency. And into June, we're showing that drop down to around 30 milliseconds of latency. And then he's also tracking the minimum latency he's getting, which is around 20, and then drops down to about 15 milliseconds, and then also that variation. And the variation we can see back in August is up around 15 milliseconds, and as we get into June, it goes all the way down close to about 5 milliseconds. So we're seeing that improvement that he's seeing. And then what we looked at after that was the comments of all, and there was hundreds of comments in this thread of other Starlink users that are also coming in to basically back up this person's opinion. And the top comment from the user FateX1994 said that, he goes into more details about the Starlink constellation, the fact that there's a version 2 of that constellation that's currently being upgraded. and that he says, every day Starlink will be better on average than the previous day because they're constantly doing this upgrade, constantly launching new satellites. And so I've got some more user comments I'll get into, but I just want to get your input on this so far, John, and see if you're following my discussion on this.
Yeah. We talked about this earlier. Starlink is awesome for people that just can't get access anywhere else anyway. The question would be: is Starlink a competition that some for somebody that's already there? Like if I have Comcast where I'm at, would I drop Comcast and go to Starlink?
Right.
Probably not. I mean, a wired connection I think is always going to be the most stable connection, right? But one of the pitfalls of Starlink could be the satellite dish. It's money up front. Now people are paying thousands of dollars for an iPhone, but they don't want to pay $500 for a satellite dish. And so it might be $500-$600 for the dish. But I heard the cost of the service for 100 meg by 100 meg is like maybe $100 a month, $120 a month, which is pretty reasonable for 100 by 100 service. And being in the middle of nowhere, the satellite, the LEO low Earth orbit satellites I think are only 300 and some miles above versus 22,000 miles above the equator for geosynchronous, right? So the problem is they're not going to be geosynchronous, so they're not synchronized with the Earth spinning. So basically, you're handing off to different satellite dishes. So people are saying, "Hey, once in a while, I look up in the sky and I can see like this something going on," and it happens. That's what it is. All these satellite dishes kind of roaming across the sky, not really roaming, but we're kind of moving at different speed than what they're rotating or going around. It'll be interesting, and I'm curious about the ping times if Starlink figured out a way to perception's reality. Maybe they figured out a way to make the ping times look lower.
Well, I am curious about that. It's very interesting because it's not like they reduced the distance between the user and the satellite, right? So how is it they're improving ping time? And I do know for a while that they were struggling as they had a large influx of users to Starlink. There was actually a big performance degradation that people were complaining about. So I think it is interesting that they said, since 2024, now there's this, whether it's real or perceived, as you say, a big increase in the user satisfaction of Starlink. And if we start, so we scraped this entire subreddit discussion, and we looked at like different ways that people looked at it. From the first one was like continuous improvement, and user FateX1994 said that the constant satellite launches is continuously improving the service quality, things like outages and stuff. User Clean Vanilla 4732 said that the packet management improvements were noted. So these are people that are actually understanding the technology. The user experience, so user M. Knockett said that it is the only ISP that is improving over time. And there was actually some other users that were commenting on that. And I thought that was really an intriguing comment because you typically don't get that comments if you're looking in subreddits on different cable operators. Like we don't necessarily say, hey, this cable operator is improving their service every single day. I'd love to see that. And then stability gains, reduced ping and fewer dropouts from user Crixial. So these are really interesting things, especially if we think, there's probably more and more users out there. And then rural versus urban access. And you mentioned this, like people who can't get fixed line access, like DOCSIS or fiber, probably are going to go this. So in the rural benefits, it's essential for underserved areas from user Sierra 117AU, and in the urban shift, fiber is reducing the reliance on satellites. So John, I think that's specifically to your point. Those who can get fiber or those who can get a really good DOCSIS connection are probably not likely to use a satellite connection.
Oh, the one I've heard is really advantageous is it's a little bit more money, but it's a portable, so that if you have an RV, you could do this Starlink on the RV,
yes,
and move around wherever you want. So that right there could sell big time. A lot of elderly people just traveling around and having access because you really need it now. Internet access is like a utility now.
It's
right? You need it.
Almost mandatory.
Yeah.
if you're working, if you have kids, anything you're doing, you almost always have to have some type of required the internet access. I don't know how you survive without it.
One other one other one that could be considered competition, which I don't think it's really kicking off, is because it had a lot of fanfare, was 5G, and the 5G hotspots and the T-Mobile stuff, Verizon, it comes with caps, and it's just not as reliable, and the speed's not there. It's good if you can't get anything else, because it is what it is. But yeah, if you can go wired line, that's probably your best bet. Can't do that, probably going to go Starlink. Can't do that. And then maybe you can self-service hotspot or something.
Yep. So a couple questions in the chat here. Jeremiah says, can you outline this usage case for when to use or support RMD versus RPD? What about converting the iCMTS to vCMTS in the same platform or chassis? These are some really good questions, Jeremiah. I think we can spend a couple minutes on this. So let's take the RMD versus RPD, and John, I think we should even say, like, the RMD remote Mac device for RMD, right? That's RMD, and then RPD remote PHY device. So the difference being remote PHY device. We kind of alluded to what the RPD, the remote PHY device, is. So if you have the virtual CMTS, you have your server in the head end where the intelligence of the CMTS is really in the server. That's where your Mac processor is. All the computations are happening in that server. The RPD, that's where the RF goes. That's where we're taking out kind of an analog node, a dumb node, and we're putting the RPD in there. And that's so your server, which is the virtual part of the CMTS in the head end, is going to send that digital signal to the RPD, and then the RPD is going to convert that digital signal into an RF signal to transmit to your subscribers, and then your subscribers are going to send an RF signal back to the RPD. The RPD will convert that RF signal back into a digital signal and send it back to the server. So that's what the RPD is. John, I'll let you take the RMD.
So originally it's kind of like, you start off with stability and keep it simple, stupid. And we knew how the CMTS worked. Everything was integrated. Everything worked fine. We moved into something called modular CMTS, but it was modular, but only maybe 10 feet away. The edge QAMs were external to the actual CMTS. And they said, well, what if we took this further? We took the edge QAMs and moved out to the field. But the timing between upstream and downstream can get a little sketchy. So it's like, if we're going to put the downstream further out in the field, we got to put the upstream in there too. So we need a remote PHY device to do the upstream, downstream chipset, Broadcom, Intel, whoever it is, to convert that signal to digital and analog at the node. But then the question was, do we do the DOCSIS scheduling and the intelligence and the computations out there in the field or in the head end?
Yeah, like where's the best place to do that intelligence? Right?
Where you have stability, where you can do an upgrade, where you can have economies of scale. So you already have a CMTS, and it's serving all these different nodes. Why don't we just keep the smarts in the CMTS, centrally located, and put all the dumb stuff out in the field? The PHY. All it is the physical layer. Put that out in the field. So that was RPD. That was our first foray. That was the easiest way to start. Most people were upgrading analog nodes to digital nodes, same distance, 20 kilometers, 30 kilometers. If you want to go super long distance, that delay of converting the physical layer RF into digital, send it back on an optical link that could be 1,000 miles away is doable. But if the scheduling of the upstream request grant cycle of DOCSIS has to go all the way back to that central location that's 100 kilometers or 1,000 kilometers away, that delay could affect my ping times, my latency, my request grant cycle, my actual throughput. So there was always concerns about where am I using this? So remote Mac device puts the scheduling out in the field. So you're putting some of that complexity not in the head, but out in the field. That gets it closer to the customer, so ping times are better, latency is better, gaming could be better. But in a normal situation where nodes are only 20 kilometers, 30 kilometers away, it's no big deal. Right. But if you're going to collapse a hub site and get rid of everything in the hub site because you have all your content being locally or sourced at a central location. You might have, oh, I have a hub site here that I just bought from mom and pa, and I don't need any of it. I have all that content further back, and I can do a digital link and bypass that hub site.
Yep.
I don't need it anymore. Or the hub site just an optical retransmit location. There's no RF there anymore. But so now my CMTS could be a lot further away than where they used to have it in the hub site.
Right.
So I got rid of it. So now it's farther away. Maybe in that situation, I'm like, maybe an RMD would work well because I'm going 500 miles away. Right. And we've shown some of that where we even did it with an RPD, and we were able to go from Raleigh to Atlanta and still get really good speeds with a DOCSIS 3.0 modem because of how it does upstream bonding. So if you try a 2.0 modem, request grant on a single upstream, it's painful. But with a 3.0 modem, 3.1 modem, OFDMA, you got enough speed, you got multiple requests. So the request grants, it was perfectly fine.
I mean, so is an RPD or an RMD better from a latency standpoint if your distance is small, or are they on parity?
I would say on parity. If the distance is long, then an RMD is going to be the way to go.
Yeah, and that distance, that long distance, is it more than 10K? Is it 50K? What do you think becomes the point that it really starts to be, okay, in my environment, an RMD
The original DOCSIS spec was a one-way transit delay of 0.8 milliseconds or whatever it was. It's written in the spec. You do the math on fiber and the velocity propagation, all that, and it ends up being 100 miles.
Yes.
So we always quoted you can go
100 miles was that 800 millisecond spec in DOCSIS.
But who could really do analog video 100 miles unless you were daisy chaining EDFAs?
Yeah.
Yeah, you'd have to do a 1550 nanometer light to an EDFA, bump it up and run it again. South Dakota, they did that, right? There's a couple systems that were 75 miles away.
Midwest, you got some expansive territory out there, man.
Yeah, exactly. But in a normal situation, they were like 20 miles, 30 miles, whatever. So yeah, an RMD would make sense if you're going super long distance, and I'm worried about delay and latency and request grant cycle of DOCSIS. I'm trying to think what. Oh, how about this? One of the problems with RMD was more processing, more power, more heat.
Right.
We had limitations in how much power the node was allowed to consume. I think we had to keep it under 50 watts, wasn't it?
I think they've increased that spec now because of RMDs and RPDs. So I don't recall what it is off the top of my head, but we have more than 50 watts to deal with, or to put in our RMDs. So, but to your point, that first RMD is going to be pulling more power than what an RPD is. However, you're going to have that power probably compensated for in a vCMTS platform in your servers in the head end. So it's where you want to put your power.
Exactly.
Power is going to go someplace because you still have to do that same compute, that same processing power. I know with RMDs, operators that have RMDs, it's like having a CMTS at every single node. So you have to have that management versus a vCMTS. You have the vCMTS in your head end or hub site, and then you have just a bunch of RPDs, which look way more like your conventional nodes. There's trade-offs with both technologies. Back into our chat. I Carry Noise. I like that name. Hello, these. What is RF node segmenting's downside? So we got to explain RF node segmentation, John. You have a fiber node. You have fiber going into it, and it has multiple RF ports. Without node segmentation, that fiber going in feeds all of the subscribers off of, if you have a three output node, that downstream is going to be feeding all the subscribers off of all three output ports the same, and then all of those subscribers coming into that fiber node are going to be on that same upstream. Basically all the noise from all the subscribers, all the traffic from all the subscribers are going to be coming into the node, and they're going to be combined together. This is without segmentation. Now, John, what happens when you segment a node?
So here we're talking about capacity issues, right?
Yes.
And there's two ways to address capacity issues: add more capacity, or get rid of your subscribers.
Yeah. Oh,
So,
those
it's
darn
like,
subscribers.
yeah. So having a lot of subscribers is a good problem to have, but then they complain if everyone's trying to use it and you're trying to
Yes.
offer higher speeds because of competitive pressure. So that's driving your speeds, which then the customers, you give them speed, they'll use it. They start using it, and everyone's using it, and they have capacity issues.
Because they're
So I can
sharing the
either
same fiber. They're sharing
you're
that same
sharing one pipe.
downstream.
So you make the pipe bigger by adding capacity, or you take that pipe and you segment it out.
Split
You
it in
put
half.
less people on a pipe. You segment your node. The problem with segmenting a regular fiber node and not doing remote PHY devices and all this is RF connectors. If I take one node and make 3 nodes in that same service area, those 3 nodes come back to make a bunch of RF connectors in the head end. Now I need more CMTSs, RF ports. Because if you're going to take the optical node and come out with RF and just combine it with another optical node RF, you didn't save anything. You just combined the noise to 2 different fiber nodes. So if I'm going to segment the node, I'm going to keep it segmented all the way through. I'm not going to segment the field, but not segment the head end.
Right.
You understand what I'm saying?
Well, yeah, because you could split the users at the node, but if you're just going to combine them again at the head end, you still have the same number of subscribers and the same noise back at the head end.
Yeah. So it's like 1 step forward, 2 steps back, I think. So so segmenting the node makes sense, but what about your geography, your topography, geography, demographics? One node could be feeding 10 miles and you're only hitting 10 people.
Yep.
Because
the segmentation may not be even, is what you're saying. I could split that node, but it may be very, very lopsided when I split it.
Yeah. I mean, one node could be feeding near a college campus and it sucks during school year, but when everyone goes home, it's fine.
Correct.
So, yeah, it's with virtual CMTS, that's where they'll have the luxury and autonomy, carte blanche, one of those words, where you can allocate more not spectrum, but speed, more capacity to different areas on the fly. You can automate it where, hey, this capacity was above 80% for 40 or 90% of the time. Well, we need to rob Peter to pay Paul. There's a couple servers over here that are getting underutilized. Let's pull some service group information from those and run it over to these RPDs. Now they have more capacity.
Correct. All right, so I think that covers that. JazzCat 1002 says, so similar to cell towers for cell phones and when moving around. So I think this goes back to the conversation we're having on Starlink. James Long says, don't call PHY dumb. Thank you, James. As an RF guy, I really appreciate that.
I'm a PHY guy too, so
yes?
when you're a PHY guy, you're calling yourself dumb, that's fine.
Rock on, James. I Carry Noise says, yeah, they do. I don't know what, James, or sorry, I Carry Noise. I lost the context on that. So, all right, thanks for, please drop questions in the chat and we'll get to them. John, I want to get to Google Fiber next. That's next up in our competition zone. This one I titled, They Say It's Worth It. And this comes...
Oh, God. Go back. Ron's going to have a heyday with this. It is worth it.
Fibre.
You're missing the contraction. The apostrophe.
Apostrophe S.
It's.
It is worth it.
Gotcha. That was
all right. Good catch. So again, another subreddit on Google Fiber. I dove deep in to see what Google Fiber users think of Google Fiber. And user Megabax9573 says, Google Fiber is putting wires in our road. We pay like $240 a month at Xfinity, and we get fined if we use too much data. Google Fiber, so they gave the pricing, $70 a month for unlimited. If you have Google Fiber, what do you think of it, and is it worth it? So if anyone in our chat room has Google Fiber, or if you're watching this, let us know below. We'd love to know what your experience is with Google Fiber. So we scraped all that subreddit, and we got some input from people that are using Google Fiber. These were some of the top comments. So, and there was a lot of consistency. There was a lot of input on this. So consistently was it's like $70 a month, unlimited data, versus, and we got a lot of feedback on like why is it seemed like Comcast got the most hits. So my perspective is Google seems to be targeting Comcast markets. I didn't see anyone else writing in from any other MSO or that had any other cable operator service. So I think that's the first takeaway is if you're a cable operator, Google's targeting specific cable operators, and it seems like Comcast is the one that they're targeting right now. But the big differential here seemed to be like users were really going for that. I want to pay less for data. And it didn't seem like anyone was taking any other, like, I'm not sure Google even offers any other service. I'd be very interested. Does Google offer any video services or anything like that? Because there is a big disparity there. These people that are paying $240 a month are getting much more than just data from Comcast. I have to believe that. They have to be getting video and voice and things like that. I'd be shocked if Comcast is charging $240 a month for just data. The no data caps. Oh, go ahead, John.
You don't know if it's apples to apples, right?
Exactly.
So with their Xfinity, they probably have, they could even have security set up with the Xfinity. But the problem, I think, with Google would be, one, availability, if you can get it. They're probably not targeting, I don't think they're targeting or have it out for Comcast. I think they're just targeting where they can make the money.
Right.
So they're going to look at cities, right? Affluent cities, people with money. I mean, even though they're offering it cheap, maybe that's their introductory version, and after 1 year, they hit you hard. You know how the vendors do that? It's like, oh yeah, introductory 70. They don't tell you when that year's up, and then all of a sudden you're billed for $150.
Yeah, and the $70 I forgot to mention was for an 8 gig by 8 gig symmetrical speed.
God, yeah.
It was a ludicrous speed.
Yeah.
The other thing that was really, really important to users was the no data cap speeds. So evidently a lot of these users from Comcast have data cap speeds where when they were going to the Google Fiber, 8 gig by 8 gig, no data cap speeds. And then the user experience. So they were highly, highly satisfied with the user experience. So user Minashot, can't pronounce, we get the slide back up there, Mia. They were highly, highly praised for stability and reliability. This is probably because it's fiber. So, I mean, there is traditionally fiber. You do get a little bit, well, pretty high reliability on fiber. And then consistent speeds. Users reported consistent and high speeds, beneficial for activities like gaming and streaming. So we kind of talked about that. You're going to get, consistent latency, consistent speeds on fiber. We got multiple users. User Able Discipline 9336, user Waggy 401, also talking about that. I'm putting the users in there and putting the subreddit thread on there just so people can, if they're questioning, they can verify what I'm saying on here. And then comparison to other ISPs. Again, they're saying just consistently described as better in terms of cost and performance and customer service. Multiple users indicating that. And the switch motivation, many users highlight the significance and improvement in service quality after switching from other ISPs. There was a huge difference in support. And for a lot of people, this was important. Google got very positive feedback on customer service and responsiveness. And there was also the user portal for Google. People could go in and change their speed tiers. That user portal from Google was a huge difference, according to subreddit threads, from what they were seeing on other ISPs. Installation was extraordinarily easy. Potential issues, some users did report occasional outages on Google Fiber. So Google does have its own growing pains, despite some comments. So it is not perfect. I got that. And the general sentiments, overwhelmingly positive sentiment with strong recommendations to switch if available. And I think that's the big thing, John, is we saw this with Google Fiber's first rollout with gigabit symmetrical. It was very, very limited. Now they're doing this, more than, it's like this 8 gig symmetrical. I think it's going to be very, very limited rollouts. I don't think they're trying to target the whole US. We even see this with AT&T and Verizon. I think we mentioned this on our last show. They only, I think AT&T has the highest fiber percentage rollout, about 16%, and Verizon is only about 11% across the entire country. And Google is way less than that. So if you want Google 8 gig by 8 gig, you're probably going to have to move to get it. So it's an opportunity, but
Yeah. I mean, think about it. Video is probably one of the biggest downfalls of just doing Google Fiber, because you're not going to get the video content that you would from a local provider. You might not get the sports channels. You might be a cord cutter anyway, so you don't care, and you're just going with over-the-top video, which is fine. But then I take a step back and I'm thinking, what is Google's primary cash cow? What is it? What are they looking to do? Like, I felt they were deploying fiber to get the industry off its butt, to get the MSOs to deploy 3.1, 3.0. And I think it worked. It worked well because we didn't have people clamoring for really high speeds until there was a marketing pressure, competitive pressure. So, well, they can do it. Why can't you? So, okay, we can. DOCSIS 3.1. That's what helped push 3.1 faster than we probably would have done it, which was good because if we didn't have 3.1, we would have been stuck with COVID in a bad place.
yes.
We would have been in a bad place. But we had plenty of capacity because of that. So the question is, in my mind, I'm just thinking out loud, Google wants everyone to have higher speed. Why? Not because they're making any money.
What's coming down the road?
They're not making money charging $70 a month.
Yes.
They're probably losing money. So why do they want everyone to have these super high speeds? And it's probably other stuff coming down the road so you can do it at home. It could be AI. It could be some other app we haven't really thought about. And then that app is going to cost more money. It could be uploading information to your Tesla car to make sure it's up new downloads and uploads or whatever. And Google's working with Tesla or who knows, right? I always think there's something else. There's something further out, 10 years out. And these guys are smarter than us.
And when Google was pushing out gig by gig symmetrical services, we were all saying, we don't need gig services. Why are we doing it? Yeah. But as a cable industry, we're all now pushing to get gig by gig symmetrical services. JazzCat102 says, I don't think the average user would ever need 8 gig symmetrical bandwidth, maybe max of 1 gig symmetrical bandwidth, depending on how many devices in the home. And I think I completely agree with you, JazzCat102. Today, we don't need 8 gig symmetrical bandwidth. Just like 5 years ago, we didn't need 1 gig symmetrical bandwidth, but now we're all driving towards that. And JazzCat, I saw your comment scroll by where you said, I think some customers don't understand the pricing differences when we were talking about the difference between getting, paying $70 for data only and Comcast charging $240 for the complete package of voice, video, data, etc. Totally agree with you on that. And Jeremiah, I agree with you 100%, man. It is easy to keep people happy when your entire network footprint is smaller than other MSOs have in one city. It's easy to manage a small plant. When things grow, things get complicated. And Google does not have scale right now like most MSOs have in scale. So yeah, that's a game changer when your systems get really large. James Long says, yeah, Google probably wants people to have higher speeds because all of their cloud products, they sell G Suite now as a fully functional alternative to MS Office. And Ronald Jones says AR. Is that Arkansas? Is that where Google Fiber is, I'm suspecting? So that's probably one of their markets.
So augmented reality, right?
Or augmented reality. Yes, AR. Okay. Good.
AR and VR.
Yeah, I totally misread that. Good job.
Or no, maybe he's a pirate. He's just like, arr.
Yeah. So James says, fully functional is debatable. Good point. So fully functional. So I think, we're going to see, again, how Google Fiber plays out. We watched them do it with gig symmetrical. Now we're going to see it with 8 gig symmetrical. And I think now this takes us into, low latency. So John, in our last episode, we got a few more minutes here. In our last episode, we talked about DOCSIS 4.0, and we failed to answer a key question for our end users: is what will DOCSIS 4.0 bring us, or when will DOCSIS 4.0 bring us low latency? And John, we don't have to wait for DOCSIS 4.0 for low latency, isn't that right?
Correct. I mean, LLD, low latency DOCSIS, was part of, I wouldn't say it was part of 3.1, but it was in the same time frame as DOCSIS 3.1.
Correct.
There's about 3 or 4 different features with low latency DOCSIS. One of them was how to sort of bypass the request grant cycle or make it faster for maybe a mobile backhaul. Maybe I wanted to use the DOCSIS plant to have a 5G small cell site where I live in the middle of nowhere, but they didn't want to put up a small 5G cell site, but there was a DOCSIS plant there, and we could just have that run over the DOCSIS plant. So it was something to address that. And then there was, what's the other one called? PSP?
So there's AQM. AQM for
adaptive queue management. That was to make it a little bit faster in the CMTS and the cable modem. What was the other one?
The grant, the
PSG?
PSG.
Proactive
service grant.
Yeah. And that was to try to make it faster than just a normal request grant cycle.
Yep.
So that proactive service grant could deal with these long latencies, especially if you did RPD and not an RMD. And if you did an RPD, super long distance, the proactive service grant, PSG, it's another problem with the PSG. It's another service flow.
Yes.
It's something you have to put in the CM file. Kind of like in the CM file, you could have a UGS grant for voice traffic. So it's another service flow that has to be configured in the CM file.
Because what we'll do is we'll say, like, hey, this person's just surfing the web. We don't care about the latency of this traffic, but this person over here is playing a first-person shooter game, so we want to make sure that gaming traffic gets a service flow that has a certain latency associated, a guaranteed latency associated with it. So that when someone starts watching Netflix, for example, which Netflix can spool up and spool down, it doesn't care about the latency. That big surge of traffic associated with a Netflix spooling up doesn't impact the person in that same house, or maybe in the neighbor's house playing a first-person shooter game. And there's some other proprietary techniques that different vendors have in their CMTSs and their modems and stuff that can also support low latency DOCSIS, or also, as you said, for 5G, low latency backhaul. These are all in a DOCSIS 3.1 specification or other cable lab specifications. It's up to the cable operator if they want to enable these services and or charge the end user more to take advantage of these services. Cox notably is one of the cable operators that offers these for gamers as a upcharge service. So it's out there, folks. DOCSIS 3.1 supports it. You don't have to wait for DOCSIS 4.0 to get it. Talk to your vendor if you don't know how to enable it. So we got a lot going on in chats. Folks like the pirate art. So we got to do a chat on there's like a pirate day, I think, out of the year. So 4D gaming, holography, communications, transporters. Guys, I've been waiting for the transporter so I don't have to take flights anywhere. If that comes, we'd love that. Can Deutschland 3.1 still work on regular 6 megahertz channels or solely 192 megahertz channels? So part of that came in DOCSIS 3.1, right? That we got away from 8 megahertz channels and we only use 6 megahertz channels, John. So that's
correct.
I don't think that was in the 3.0 spec. That was part of the 3.1 spec.
Well, 3.1 was OFDM.
Yeah. So did we get rid of? Did we get rid of 8 megahertz channels in 3.0? Was that when we got rid of 8 megahertz? I can't remember if it was in 3.0 or 3.1. It was definitely in 3.1. We no longer have. We only have the concept of 6 megahertz SC-QAM channels.
3.0 we still had 8 because what was nice about Annex A, right? Annex A is Europe.
We could do 8 megahertz bonding if we wanted to in the US to get increased capacity.
More speed.
Yes.
Because the modem still had 24 channel capability, and 24/8 was a lot more
Yes.
than 24/6s. Yeah, so if you went Annex A with Euro DOCSIS, you could get more speed out of it.
And there were some operators in the US that were taking advantage of exactly that, but we lost that capability. That went away with DOCSIS 3.1 because we no longer have 6 or 8 megahertz channel capabilities in DOCSIS 3.1. But we did gain OFDM in the downstream, which goes all the way up to 192 megahertz wide channels. And in the upstream, we can have 96 wide megahertz channels. So a lot more capacity with
that. The minimum channel for downstream OFDM was 24, which is a perfect combination of 6s and 8s.
Correct.
Right?
So you can kind of mix and match.
Yeah. So the minimum you can do on downstream OFDM is 24, which would fit into a Euro DOCSIS plant or because normally you have your channel set up. So he's like, I don't want to lose any spectrum. So I hope it fits perfectly.
Yeah, great question, Dominic. First time I've seen you on the channel. Thanks for joining us. Dominic also says, I think he's giving us a clarification. Sorry, voice text. I meant DOCSIS. 3.1. Somehow we figured out what you were saying there, Dominic. He also says, Anquin, I think this is another voice text, will never die because a lot of engineers I know say everything comes from QAM, even the internet. Can you do regular linear cable on DOCSIS 3.1? So I think that depends. So linear cable, I'm assuming he's meaning like analog cable on DOCSIS 3.1. And I would say if you're using an integrated CMTS, like we talked about earlier, you could still use that traditional analog linear cable if we're understanding that correctly. But if you go to a vCMTS or any type of DAA architecture where you're using RPDs or RMDs, as we've talked about in this show, then no. Anything analog, anything of linear is going to go away, and you're going to have to upgrade to technologies that support DAA type architectures. And we've done shows on that in the past talking about those. So next up, Ronald says EuroDOCSIS is 8 megahertz, I believe. That is correct, but there are also 7 megahertz channels within EuroDOCSIS. But it's predominantly 8 megahertz.
No, let's not say
7 megahertz on video, 8 megahertz on DOCSIS. Yes.
It's PAL B versus PAL G.
Yes.
So PAL B goes up to about 300 megahertz, and it's 7 megahertz chunks. And from about 300 megahertz up, it's 8 megahertz chunk, and it's called PAL G.
Correct.
Somewhere in that range. Yeah, it's a little strange.
So, and Dominic says, and they still could use 192 megahertz channels for regular digital cable and high def, just not internet. Correct. Well, that depends. You could use the 192 megahertz OFDM channels if all of your video is IP-based video. So you can't, you have to convert your video into an IP video like John was talking about earlier in the show, an MPEG-4 based stream, then that could be transmitted over your OFDM channel. But keep in mind, you would be taking away data that would be going to your end subscribers. So yes, you can send IP video over any of your DOCSIS channels. It takes capacity away from data that would be going to your regular data subscribers, but cable operators are doing that. That's not uncommon to send IP video over your DOCSIS channels. And I think we got through our questions, John. Anyone else? Drop them in if you got any comments on that last one on the IP video, John. I think that's pretty standard for operators to be doing today.
No, I mean, I think we talk about cord cutters. I think a lot of people are just doing their video over the top anyway.
And a lot of operators,
So it's not like the operator needs to dedicate any speed on DOCSIS for a multicast or a simulcast or anything. Customers just pull up what they want. It's all IP based.
Correct.
So they go to YouTube, go to Disney Plus, Prime TV, Netflix, and just pull down what they want, and just looks like data to the cable company. Just sees more data.
It's just data. Yes, absolutely.
And then that over-the-top video is adaptive bit rate, so it will adapt its bit rate based on how much speed you have, the screen you're looking at, right? So if you got good speed and you're looking at a big high-def TV, that Netflix show could be in 4K, requiring 20 megabits per second or something crazy, right?
Exactly.
Whereas I'm looking on my little phone and watching it, it might drop down to 1 megabit per second. Who knows?
Exactly. All right, John, that is another show we got done. Did we say this is episode 98 or 99 today? 99. This is episode 99. Our next episode, we're going to hit 100 episodes. After like 10 years of doing this, it's awesome. So we hit another 100 episodes, I think in August we're going to schedule that for. Anyhow, we'll be teeing that up soon. So, John, great episode today. Chat room, you guys were awesome. Thanks for all the great questions. Thanks for all the great chat. Folks, please like, subscribe, hit that notification bell. We greatly appreciate that. And if you didn't get your questions in today, please drop them in the comments below. We'll do our best to answer your questions.
When is Expo?
Expo is in Atlanta this year in September. My home city. So I'll definitely be attending. OpenVault will be attending there. John, be sure to get down here if you can. Love to see you in person. And folks, join Expo if you can. Join us there. We'll see you live. Thanks again, John. Thanks everyone for joining. Great episode. Can't wait to come back and do it again. We'll see you soon, everyone. Take care. Have a great weekend. So long.
See ya.